Huebner. I forgot the beginning of your talk. It was great. It was, what was the beginning? What's the first part of your talk?
First part of the talk, deploying proprietary software with Nix, or how I learned to stop worrying and start loving vmTools.
Right. Now, does anyone know where that sort of subtitle, how I learned to stop worrying and love something, came from? Okay, I didn't know how current that was. I just wanted to check. Okay. Thank you for your patience.
I confess, I'm actually kind of a fake Kubrick enjoyer. I've never seen Dr. Strangelove. Also, just as like a minor errata, it's come to my attention that there's another talk also on Nix on Saturday with the same Dr. Strangelove shtick. I did not know about this beforehand. You got to believe me. I didn't copy them. If you're here for that talk, sorry, but maybe also stick around for this one. You might enjoy it. So yeah, and the one thing I just want to say before we get started off, so the title is like packaging proprietary software with Nix. Proprietary is really pulling double time there. That could also be binary software, source not available software, non-free, both non-free as in beer and Libre software. So a variety of things. I mean, in this case, I'm going to be going through like a case study of a specific example, but the techniques will be more broadly applicable. It kind of ticks all the boxes. You know, costs money. You do not have rights to it, et cetera, et cetera. But the fact remains that sometimes you do have to use that software. So being able to use that with Nix when the time comes can be a pretty handy skill to have. All right, so let me just get started here. So who am I? Why should you listen to my ramblings? I am a Nix on Darwin enjoyer. So admittedly, I don't use NixOS as my daily driver. That having been said, I am an Emacs user. That's got to give me some street cred in the Linux community. But yeah, both Nix on Darwin, like both Nix Darwin, the setting for configuring your Darwin setup with Nix, like NixOS, which is pretty awesome, and then also just Nix the package manager. So if I ever open a PR on your package and you're like, oh my God, who is using this on AR64 Darwin? Sorry, that may be me. Yeah. So I'm also like a bit of a jack of all trades, a dilettante, if you will, some may say. I use Nix to do a variety of things. So I'm actually a quantum physicist. If anyone wants to talk shop after the talk, feel free. I do like quantum coding theory and stuff like that. But I also do cybersecurity, like software engineering. I mean, like I'm a student, so I'm in all these classes. So having like a Nix dev shell for each class, like that's super handy. And things will just work a year later when I inevitably need to go back and run some code from two semesters ago. And then more importantly for this talk, I'm a frustrated user of Synopsys VCS for reasons I will get into later. But yeah. So the case study, this is going to be the Synopsys EDA toolchain. So this is software for, if you have VHDL, like system Verilog code, this is what actually transforms the code to the gates and transistors that you can then hand off to TSMC or Intel, whoever, to fab the chip. Also for simulation of the chip, like an open source alternative is Verilator. And Spyglass is the linter. We'll talk about that in a second. So basically, I'm taking this computer architecture class, right? And we're using this tool chain, yada, yada, yada. The general setup is, okay, you log into this server, this RHEL 7 server, and this is what you run all the code on. And I'm sitting here realizing, I have this Ryzen 7 machine, 8 cores, and I'm using that as like a dumb terminal to just SSH into this one virtual CPU machine that's running synth. And this is a compute-bound task, right? Like this simply does not make any sense. I'm not waiting 20 minutes for my code to compile. Like that's completely unacceptable. So, I figure, okay, let's just grab not the source, but the binary redistributable off the server. Please don't tell Synopsys that, but yeah. And there's no source, but we also don't have to compile anything, so that's kind of easy. It's just a bunch of bash scripts, Perl scripts. What's the worst that could happen? Oh, you sweet summer child. Yeah, it was not very straightforward, and that's why I'm giving this talk. I'll hopefully save some other people the distress that was caused to me by Synopsys. Okay, so the first thing you should always do when you're any software, proprietary or not, you should always hit them with a Nix shell. This should always be your first attempt. I cannot tell you how many times I've assumed something is not Nix packages and then try to make a package for it only to realize like, oh, it's in Nix packages unstable, or oh, it's in Nix packages master, and I just didn't look for the PR. I've even opened PRs, it's already PRs open. I've had to close several PRs that way. So just do yourself a favor, do a code search, And not only on the NixOS, Nix packages repo, but do a global GitHub code search, because many times, especially for proprietary stuff that's unlikely to get accepted into Nix packages, there may be a dev shell or some other Nix expression for dealing with the software. And actually, in this case, Chips Alliance, which is, I think, a subsidiary of the Linux Foundation, had a Nix expression for this exact same toolchain, which I based some of this off of. Didn't quite work for my use case, and we'll get into that later. But do yourself this favor. It costs nothing, basically. So yeah, in our case, we don't really have anything. So a bit unfortunate, but if there was, I wouldn't give this talk. So yeah. Okay, so I'm a theorist. So the first thing we want to figure out is, like, in theory, what does a program need to run? So okay, it's not in Nix, whatever. But before we actually run the program and figure out what's missing, why doesn't it just work out of the box? What does a program actually need to run? I'll give you an example of a program that does just work out of the box, which is highlighted below. Basically, if you don't have any dynamic libraries, you're not doing DL open at runtime or anything like that. You're not using any unstable OS ABIs. Generally speaking, this is never an issue, but if you're doing some jank stuff, it might be. And the machine you're actually running the program on, it's the same operating system, Linux, because otherwise if you do a syscall, Linux and Windows syscalls, like, they don't make sense. They don't really interoperate. And it's the same architecture or file type, or at least your machine knows how to run those. So you can use QEMU as a bin format handler, so you can run ARM binaries on x86. I mean, it's not on by default, but you could. Things will most likely just work out of the box if that's the case. And especially with Nix, or with really any software package, the main thing here that's causing the throwing a wrench into the mix is this dynamic libraries aspect, and that's what I'm going to be focusing on today. But there's other things too, which we'll get into. But yeah, just as a side note, things do not just work here. This is abandon all hope, ye who enter here territory. So first thing we're going to do, Spyglass. This is the linter. This is the synopsis linter, telling me that my code is bad. I already know my code is bad, but I have to use a program to tell me. Like, it's kicking a man while he's down. So the first thing, again, just run the command. Just you have your SG shell in this instance. Just run it and see what breaks first, because you may be surprised that things don't break. Although in our case, things definitely do break. So okay, we've got a few lines here. These commands not found, sort command not found. A lot of these are in core utils. And at first, I think that's kind of strange, because actually I'm on a NixOS system, but I do have these utilities installed. I have core utils in my environment.system packages. So that's a little weird. We'll get to that in a second. But the more concerning thing is here, a Perl installation was guessed incorrectly, or the installation is corrupted. Ugh, that doesn't sound too good. So we move on. Let's check out this supposedly corrupted Perl installation. So run LDD. This is just to see all the dynamic libraries and what it resolves to. And at first glance, we're like, wow, this is great. It's resolving most of them, except for libcrypt.so.1. So we might be in business here. I will say this output is a little bit misleading. LDD itself is from glibc bin. So when you run this, it's essentially inserting its own path into LD preload. So I don't actually have lib64 LD Linux symlinked to this glibc path in the store. But we can work around that. It's like, okay, clearly we need glibc as an input, and then also this libcrypt, which is not too bad. It turns out that's actually a Nix packages, so life is good for now. But yeah, there are some issues. Okay, getting back to the command not found, there are some very, shall I say, defensive coding practices in this package. The most egregious of which is probably this, just hard coding the path. The program thinks it knows better. It's okay. It doesn't, but this happens. It's okay to be wrong. In this instance, it's really annoying that the program is wrong, because I actually want to use it and it just does not want to be used. But whatever. Okay, we might be able to patch this or something like that. We have this other gem. There's like a species genus thing, which I appreciate the people who write the code. They're trying to have fun. I'm kind of miserable at this point, so it's good to have a little fun in there. And it's like, okay, so they support Linux 2, Linux 3, Linux 4, Linux 5. Oh, I'm on Linux 6. Okay, so it just doesn't, it's not in this case expression, so it doesn't work. Nothing, like, they didn't test it on Linux 6 to see that it doesn't work or anything. In their defense, Linux 6 was released in the future. When this is from 2021, Linux 6 wasn't released until I think either late 2021 or 2022. So I can't give them too much trouble here. Although they do support SunOS, also DOS, HPUX, AIX. These are way before my time. I don't know why you're still supporting these in this day and age, but the computer architecture industry is it's a very strange place, I suppose. In the comments, I will just say they're very amusing. There's like DOS bad, Unix pleasing. There's 18 watch out comments, which he's like, okay, if you're gonna watch out, like just fix the code, like just write it correctly the first time. But I digress. So yeah, we could. This is all part of that bash script. This is that environment.sh file that was giving us this trouble. We could maybe patch this out if we put this into a Nix derivation. Again, we don't want to just patch it impurely because that's not reproducible, right? But there may be something else. Maybe we don't even need to go into the store, and that would be good because this Spyglass package, it's like 3 gigabytes. It's actually quite large, so having to pull that into the store every time may not be so good for just disk space usage, especially if we. I mean, it may be good. Like we'll get into that later, but in this case, we don't need to bring it into the store because we're going to use this handy dandy thing called build FHS environments. This stands for file system hierarchy standard. So NixOS does not follow that, and even if you use Nix on something that's not NixOS. Chances are some of these binaries that you need will not be in their expected locations in like user bin and bin, because if you're installing things with Nix, with like Home Manager or something like that, it'll go into, I forget the exact path, but it's not that. It's not part of the FHS standard, or FHS. So again, we don't actually have that many libraries this time. Really the only thing that's running here is Perl. It's just a bunch of Perl scripts, because of course it is. And we just want to let the program remain blissfully ignorant. It's wrong, that's okay. It can keep its small, sheltered worldview within the confines of a CH root, and it thinks everything is in bin, and everything to it is in bin, and life is good. Now, we do solve this issue of the uname problem, where we're on Linux 6, and it only supports up to Linux 5. That having been said, there's a cool package called deterministic uname, which lets us just shim out uname, and we can basically return whatever we want. In this case, I'm actually doing, I think, Linux version 4.18. This is just to make sure, because I got it from a server running 4.18. I just wanted it to remain as ignorant as possible, that it was not running on that machine. Also, in case there was someone monitoring the network traffic or something for the license check, I didn't want to take any chances, man. Can't be having the Synopsys police after me. And yeah, once we do this, and we, to actually enter the shell, you can do Nix shell, expr this, and then .env, and it will drop you into this ch root, and we run the program, and it just works. Let's fucking go. Excuse my French. But yeah, it works. We're in our shell. We can now use our linter. And then just before I move on, there are some other techniques you might be able to use for this. Mike92 has tools called NixLD and envfs. NixLD does put a linker in lib64 LD Linux, where programs expect it to be, and it'll use a set of environment variables to find which libraries it needs at runtime. So in this case, again, all we need is glibc and this libxcrypt legacy package. So that would actually probably be pretty straightforward and eliminate the need for build FHS environment. envfs will also, it's kind of similar in the regard that it'll take everything on the path and we'll put those programs into a virtual file system that those programs are mounted at /bin or /user/bin. So this would work even with the check that was put in place, which removes the path. Build FHS environment is not without its drawbacks. For example, you can't use setuid binaries, so sudo doesn't work. But all things having been said, this is pretty good. This is pretty good. And then just before I move on to the next part of the talk, which is the harder aspect, minimizing copy overhead. Again, if we are bringing things into the Nix store, which we will be, we want to minimize copy overhead. I'd say the first biggest thing is environment variables. So you can also do eval time versus runtime, sort of like a Lisp macro. So you can evaluate an environment variable at evaluation time, and that essentially gets hard-coded into whatever bash script or whatever you're using your environment variable in. Or you could just, in the bash script, just put $sign environment variable, like you're all used to. And this can be pretty important if if you want to have a build FHS environment, and that's a Nix expression, but the thing you're running is not in the Nix store. The other thing is lazy trees. This kind of helps when you're developing. This is also only available in determinate Nix. I don't know if it's ever going to be available in upstream. We'll have to see. I personally haven't used these, but could be helpful for your use case. And then if you are going to use require file, you have some tarball with Spyglass or whatever program it is in your case, I would highly, highly, highly recommend. There's likely a lot of things, especially if it's coming straight from, the redistributable is coming straight from the vendor or whoever you're getting the software from. There's likely a bunch of cruft that you don't actually need. So in Nix's unpack phase, I would be just ruthlessly aggressive at removing anything you think you don't need, just because, again, all this is going to take up more disk space. And then, yeah, definitely use a separate source derivation, especially if you're going to be hacking on this repeatedly. You do not want to be running this unpack phase so many times, especially when the tarballs are like, on the order of gigabytes large. Just, have it in its own derivation, and then have whatever other logic you're doing depend on that. That way you don't have to rebuild and unpack a bunch of times. Okay, so now, that was round one. Round two, Verdi. So this is a waveform circuit viewer. And this is non-trivial. I'd say the other one was like maybe trivial. This one is certainly non-trivial. It's a GUI program. It requires Qt all the way back to Qt3. I don't know why. Audio libraries, even though it's a waveform viewer, like what is it going to do? Beep and boop at me? I don't know why it needs to have audio, but yet it does. Okay. And yeah, so how are we going to go about doing this? In this case, we're probably going to use a derivation for this, right? Because it's a little bit, we can't just do the build FHS environment trick. So for some of these older packages, which are not in Nix packages, like Qt3, that was removed in like 2021 because it's a vulnerable package, we could maybe use an older version of Nix packages, like pin that and use Qt3 or whatever from that. That's definitely a possibility. If it's pretty easy to repackage it, we might, instead of just going back in time to a different version of Nix packages, which I will say that the code quality, I've been an Nix user for like more than 4 years, but the code quality definitely has increased. So I would recommend using a newer version of Nix packages where you can. But if you're using something, and it turns out like glibc, for example, is actually pretty easy to build. It's like a maybe 10, 15 line derivation. So if you're using that, it may be worth your time. That having been said, I would generally not recommend this because it's very, very easy to sink a bunch of time trying to get this to work, and then it just doesn't work. There are a lot of packages for subsystems like Qt where the build process is actually pretty annoying. So yeah, and unless you have like a pretty good estimate that it's going to work, I would recommend not doing this. Okay. So the next thing I want to talk about is patchlf. And again, if we're not running things in this FHS ch root, we actually need to change, because again, our program is still looking for these libraries. It's still looking for the linker in lib64 LD Linux, and we don't have it there. So at the bare minimum, we need to change the interpreter. This is just information in the ELF metadata. So patchlf, it's a great tool. If you use CTF, if you do CTF, you probably use this in the command line all the time. But generally, if you're using Nix, there's actually a much, much, much easier way to do this, which there's something called auto patchlf hook. And you just add that to your native build inputs, and it will scan through your, I believe it's both build inputs and runtime dependencies, and it will go through anything in like out lib or out bin and essentially run LDD on it, see what libraries it's missing, and then add libraries that you specify in the derivation. And most times that will actually just work. So for games especially, I'd say is where you see the most common usage of this. And also, we might be able to remove some of these libraries that the program thinks it needs, but again, we know better than the program. So that having been said, unfortunately, like a lot of times, programs do not react well to having libraries that depend on be violently removed from them. So, you can try it, but it probably won't work. Also, in our case, we definitely do need an older version of glibc because the program references non-public symbols, which is a very, very naughty thing to do. Don't do that if you're building programs. Do not do that. So we would have to bring in an older version of glibc too. I'm not going to talk about how to do that per se, but it's basically just use a pin version of Nix packages or build it from source yourself. Pretty straightforward. So at this point, I was kind of tearing my hair out, and I was like, okay, I'm done with this Nix stuff. I'm sorry, I know this is PlanetNix, but I'm done with this Nix stuff. We're going back to RHEL. But then, like, ¿por qué no los dos? Like, can we have both? Like, what if we had RHEL and Nix? We had the mixture of the two. So, the kind of maybe obvious next step in logic is, okay, let's use Docker. We don't need a full virtualization. We don't need VM. I'm alluding to the title of the talk. But can we get the benefits of a RHEL 7 base image without losing reproducibility? And you may say, yes, we can. It's Docker tools. I'm like, yes, Docker tools is making its appearance. So yeah, using Nix, you can use Nix as a OCI container image builder, which some might argue is even better than Docker for certain use cases. So instead of having a Docker file, you'll have this Nix expression. It will, build image. You can have it like this. There's a lot of control you have here. I think it's a pretty well-designed package, or I guess a build support package. And yeah, the only problem is, again, we're still at this issue. We still need libqt3, which is nowhere to be found in Nix packages. So sure, we can build something in Nix and then add it to an OCI container image and then run that. But we can't actually do the step of building it. Like that's what we care about. But this is how you would do like a base CentOS image, for instance. And so now, enter vmTools. Ooh, vmTools, what's that? I mean, at least I didn't know what it was. But this is a slightly lesser known build support package that to the best of my understanding, this was used in the dark days before NixOS was the cool kid on the block. And GitHub repos actually had shell.nixes and whatnot. But there's a bunch of wrappers around QEMU, basically, so you can do something like run it in a Linux VM. It's got expressions for Rocky Linux, Debian, Ubuntu, RHEL. It's pretty cool. I'd recommend checking it out, even if just to look at it. But the thing we're really interested in is a fetch URL derivation generator. This is called RPM closure generator. And what it allows us to do is it allows us to create a fixed output derivation of RPMs from a package mirror, and then we can package exactly the same thing every time. So we have instead of like in a Docker file, you'd run like DNF install this package, this package, this package, but you don't have guarantees that it's gonna be the same. But here, we're using Nix and a Perl script to basically generate a file full of fetch URLs, which has the hash in them, but we don't have to do that manually. It's pretty great. It's pretty great. So this is less vmTools and more vmTools build support. But yeah, so we have CentOS, we have RPMs from. A lot of this is boilerplate, so it's not too important. But the idea is we have a list of RPM files in the Nix store. Awesome. You will have to change this if you have import from derivation turned off. So instead of doing import this, you would just have this and output it to a file and then import that. And then yeah, to actually use this, you would there's a run as root step in Docker build image. So you would add some extra DNF configuration to your to Etsy, and then you would do yum local install, and then you can pass in all those Nix store paths that you had from earlier. And yeah, that's pretty much it. This is a bit of a leaky abstraction because again, we're not really RHEL. We're just pretending to be RHEL, and because this is Docker, information from the kernel will bleed through. But again, we have our good old friend, deterministic uname, coming to the rescue. And so we can, again, fake and pretend that we're actually RHEL instead of NixOS, which, of course, Synopsys has never heard of. The only thing here I will mention is this isn't perfect. There are methods for detecting whether or not you're in a Docker container. So if your proprietary package has DRM or fancy DRM, I would say, and is doing these methods to figure out, is the init process system, is it systemd or is it something else? You could probably use eBPF syscall hooks or something like that. I mean, I haven't personally done this, but as a bit of bonus cred, if you want to look into this, I'm sure you could do it. Famous last words, but I'm sure you could do it. So yeah, with that, we're good. We're able to run our waveform viewer and every other program we want, because this is a pretty general technique that you can use. If you're using software that's built for enterprise Linux, you can use this to bring enterprise Linux to Nix using Docker tools and vmTools. So yeah, for actually using this in practice, I had this very scuffed setup where I ran everything in a namespace, and then within that namespace, I had a network namespace for connecting to my university's VPN. So we have some of this stuff. We do some path translation between the host and the container. And then we have a wrapper and a Nix expression. This will just wrap all the programs we actually care about running from make in a little program that will just call podman that in the container, podman exec that in the container. And this way, it's almost as if we had these binaries on our machine. Yeah. So I will say, talk is cheap. You're probably interested in actually seeing what all this is instead of just seeing on the slides, and you can't type that in. So I have all the code used for this on a QR. On this GitHub gist, which you can scan and see. I will say it gets a little bit nasty. I hid most of the nastiness from the talk because that's like public indecency or something, but it can be pretty scuffed. Like I would say my personal favorite of the worst thing is I needed to create a wrapper binary from the output of simulation. So what I did is I just checked the output of simulation if this argument was part of its command line, and then if it was, it would I set up a bash exit hook to then replace the binary with a wrapper of itself, which when run would replace the wrapper with the actual binary. Like it was terrible. It was terrible. Like you should just read it. Like you'll look at it and you're like, oh my god, this is so terrible. I love it. Yeah, but in summary, as a final word, I will leave you with some prescient wisdom from a NixOS wiki contributor, which is just link bash /bin and be happy. And yeah, that's my talk. Any questions? Well, I guess this is Linux Expo, so I guess there's not that much proprietary software in the audience, but surely. Okay, fair enough.
Great. Great talk. So you mentioned that you use Nix Darwin. So is all of this, you're running this on Nix Darwin as well, or is this on the NixOS host?
Good question. Initially, the stuff with the build FHS environment, that's on a Linux system. So a lot of this is Linux specific. I think actually the Docker container stuff, that should work on Darwin, because Docker on Darwin will spin up a small Linux VM through which this is actually run. So it only works on Linux, but you can have Linux on Darwin, if that makes sense. So I personally did not run it because my beefier machine is what I actually wanted to run the compilation on, and that was a Linux machine. But my answer is it would probably work, but I haven't tested it. So yeah. Awesome. Thank you, guys.
Thank you very much, George. That was great. I think we're done here, actually.